So we want to track our position of the train with openCV. We want some sort of marker on the train, so when the train is moving we can track the train. This is color detection, so it looks a unique color in the field and can track that single color. So if you had two matching colors, and it would get confused between which one's which is not good. So you want a unique color. Another one is the Camshift algorithm, which looks at a shape, but it's not very good. The camera one's better. Right, let's go through them. This converts your image here to hue, saturation and value. Now this is similar to color detection, right? So it converts each color, so this is black, to black, this black is black. It looks at these colors and then realize that this black is similar to the black hair, and this color here is similar to the color here. There's a lot of similarities in color, and you can see the blue is different from the yellow there. So, but there's not many unique colors in this sort of field. Here is another color which is red on the outside, and that's seeing that as white. There's no other white value, so this is unique in the frame. If we get a yellow, now this yellow is similar to the hand, it's also similar to the here behind it, so it's not the best. So in this HSV image, you can see which colors are unique and which colors are not. Right, okay. And then there's a sliding bar. So this is to show you the threshold. This is good for identifying which color you want to define. And there's a sliding bar. Right. This is quite important. Now, let's say you want to detect this red, right? So you've got to slide these until red is the only color. And you slide these until, so right now you can see the logo here. Okay, so you got to keep sliding these until, oh, we missed it. Alright, so there's, you can see that, got a vague outline. Ideally we want just this and everything else removed. So you got to keep sliding these. It's a bit of trial and error to try and make it work. Okay, so it wasn't that hard. Maybe I can do that. Alright, there we go. We got it. And there's it. Tracking object. There's a bit of noise up there. What noise up there? I'm not sure why. Anyway, it's tracking the object because that's the only unique color in the frame. And there we go. We can move it around. It can give you coordinates. And it says tracking object. It's looking at the red value in that. If there was another red value, there's a red box behind me. So there's the red box, and it can get confused with that red box there. So we just down the frame. Maybe we need to open up the curtain a bit more. So that red box, if I move out of the way, that will be tracked. And when this is here, it's confused. Which one's red? Which one shall I track? Shall I track that one? Or shall I track this one? So there needs to be a unique color in the frame. Now let's try it with this bottle cap. Now this bottle cap, you need to reset all the values. So the minimum goes back to 0, max goes back there, min there, max there, min there, and max there. And then you got to do this because this is going to be tricky to find because it's not unique in the frame. Now this is going to be tough one to find. Okay, so it's down here somewhere. Maybe we should start with this value. I'll start with something else. Okay, it's somewhere around here. See, that's my hand and there's this object. And my hand and the object are pretty much the same colour now in this HSV frame. Oops. Alright, we've got the circle more or less, and let's try and filter out all the other stuff. Okay, we've got the circle. Oh, that's pretty unique in the frame. There we go. And then it says tracking object. There you go, coordinates. Actually pretty good. Yeah, you need to be, it doesn't, it's okay, it's alright. Sometimes it doesn't detect it, it might need more surface area because there's a threshold of how big the object is and they can't see it. So as long as it's more or less okay. Actually, but this is the best one I could find. And there's a bit of angle to it, so sometimes it does, sometimes it doesn't. It can be tricky with such a small shape. Now the other one I found, let's stop that, is from the Camshift algorithm. And there's the code from the GitHub page, and just open it up and try it out. Okay, this is some more sliders, but you don't need to touch the sliders. Alright, so there's me. And you click and drag on the shape you want to track. So let's say I want to track this, I track it. It's more of a shape algorithm, and it's drawing a circle around the item I want. It's great for circles. And look at that. It works. But look, my face is also a circle, and you got confused there, which is why, there we go, see, carried on tracking. And if we find similar shapes, for example, the train is a square, but so are the gantries, they're also squares, so that can be a bit confusing. And there we go, it's finding a lot of circles in this frame, and it's getting confused. Try and find where that is. There you go. And then you have to keep retraining it, which is annoying. This is why I don't like this Camshift algorithm, because eventually it starts forgetting where it's tracked, and after a while it tracks the wrong thing. It's not tracking, I'm not sure what it's tracking now. Not tracking whatever. I think it's tracking my hand now. See, it's not that good at tracking stuff. Let's try with the original. This. There we go. But when I pass it over my face, it stops working. You can see the histogram on the right. I'm not sure what's doing that, but try and make it all black. Yeah, I'm not sure. I didn't find this to be the best. I thought the Camshift was better. But it can be tricky when you've got multiple colours on the track, and this is more of a shape algorithm, but there's a lot of shapes on the track, but none of the shapes are unique. If you look at this shape is pretty unique, and as long as it doesn't move around much, it did move around quite a bit, and it lost it. I didn't like the fact that it lost the shape. So I had a go at these two programs, Lucas-Kanade and another one, gunnar farneback, and they ran alright, not too many problems. Anyway, so let's run this Lucas-Kanade. I'm recording this because I don't think this is good enough for the presentation. So what this Lucas-Kanade one is, let's close that. Right, okay, so it looks at you click on the mouse and it draws a dot. So you need something with a sharp, so let's try this. That was good, because it's got a big contrast between the white and the black. Right? So it's good on hair, because there's a contrast, and it works on hair. So when I click on my forehead, it will jump and disappear, because there's no contrast. If I want to track my finger, it'll mess up because there's no contrast. So our train needs to have a deep contrast between it and the background. Now as you can see, this one just disappeared, so as soon as our train reaches the gantry or gets covered, we lose the point. So every time the train reaches the gantry we lose the point, it just looks silly. Yeah, and the fact that we can just move points around, I think that's just silly. Yeah, okay. So I thought this was quite strange. Yeah, there we go, got rid of the points. So if you got, so with the previous ones we were doing examples with this cup, and if I click on it, no contrast, so you can't track it. So it tries to track my fingers now. And we've got one corner, because there's a contrast between it and the outside. But before I was having trouble with that, actually getting this to click on any dots with it. Like now, I can't click, it's following something else. So This doesn't work. And let's try with this. So the contrast between the white and the red, but it just goes. I didn't really like this demo. It doesn't work very well. The dots disappear, sometimes they go, and it is in good contrast, it just misses it, so not that good. I then went to the other one, which was the gunnar farneback method, and let's try that out. There was another, and okay, so this looks at any motion of the points and draws a line between it and the next frame. So if the next frame, so if I've got this, my hand, so right now my hand's still, all the dots are still. Now all the dots I'm going to move are going to have a line on them. So it says, look, the dots have moved, so there's a line on them. So as the train is going past, it's going to see a load of dots moving out of the way like that and like that. I'm not sure how relevant that is in the demo. It's just seeing dots moving, it's not actually tracking anything. And then when I saw these reminded me of let's stop that, of these Python demos, because when I first tried it out, I tried these Python demos, and these are Lucas-Kanade, same ones. If I run this, alright, so there's a lot of dots, and there's, rather than you clicking on the dots, it shows you every possible dot and tracks you. So these are the available dots that can be done, rather than you spending some time clicking on them. And there it is. And see on that, see there's you can't click on the inside, but there's some dots available on the outside. They move around a bit, and you can tell you at the top there's about 800 dots on there. There's a lot of dots on the hair. It seems to be quite good at the hair, and the eyes, and the eyebrows. It's quite good at that. And let's close that. And there's another one which is track. This is like the first one, but it shows less dots, so the more prominent ones. And see, the only ones with the contrast, it's looking at the contrasts and edges. There's a lot of contrast between the black and the white. And here, the black on the pupil, the white on the outside. Here, nostril, beards as well on the edges, and there's a lot of contrast here, black on the white. It seems to be quite good at these contrast levels. Now if we use this for this, I think the contrast is between my hands on the outside rather than the circle. There's a tiny bit of contrast, but we seem to be losing it sometimes. So if this was a train, if the train was like that. This has a bit of contrast, so you can see we sort of got it, but we sometimes miss it. So some of the times in the demo it might not work. And the train would have to stop every time, because if you go too fast, you could lose it. Now let's say this train was black and I'm using this mouse. It seems to be okay when it gets a dot and it moves slowly out of the corner. Whereas sometimes if something passes over it, like it passes over a gantry, it can lose position. I didn't find this to be optimal, because you can lose some position if something goes under it, like it goes under a gantry. So it's tracking, goes under a gantry, loses track, and sometimes it gains tracks. But it's not that good, and they'll see straight through it, because these just look like the demos. There's one more demo, which is this optical flow. Oops. Let's run this again. Alright. Optical flow. Alright, this is just like the ones that, I think the first or the second one, or the first one, I can't remember which one. But anyway, it looks at the difference between the dots and moves them around. So these are just like the demo programs. I'm not sure how relevant these are for our demo.